Okay, so we're doing 8.1 in this section and 8.6. 8.1 we're going to do in 2 days, and then 8.6 we'll do in a day. So the mean, median, and mode, these are terms that you're already familiar with, right? So what's another word for mean? The what? Yeah, the average, okay? So you find the sum, you divide by how many values there are, okay? The median is the middle value, but this is when you line them up numerically from least to greatest. If there's no middle value, you just take the 2 middle values and find the average of them. And then the mode is the value or values that occur the most often. And sometimes there's more than one mode. That is perfectly fine. Okay, there's only one mean, there's only one median, but you can have more than one mode. Okay, so for example 1, I want you to find the mean, the median, and the mode of that data set. So the data is given in set notation here. Yes, you can use a calculator. It is going to be a decimal when you divide. Is anybody not familiar with those terms, the mean, median, and mode? And you can use your calculator to add those up, but will you write down what the sum is in the numerator? That way if something happens, we can double check and make sure it wasn't a calculator error. Okay, so what were the sum of all of our values? For example 1, what was the sum when we added them all up? Yes, 12. Okay, so when you're finding the mean, okay, we're adding all these numbers together. And then dividing it by the total number of terms, and there are 7. So when we do 12 divided by 7, we are going to be rounding to the hundreds place in this section, so we can practice that as well. So this is 1.7, and then do I round up or keep the same? Keep the same. Okay, so this is going to be our mean. Okay, now the median, when you are lining these up, something I do when I'm lining mine up is I will cross them out as I line them up. So I have 2 zeros, so 0, 0. I have a 1. I have 2 2s, a 3, and then a 4. So if there's an odd number, okay, the middle number, there's only 1. So there's 3 numbers on the left, 3 numbers on the right, which means this is going to be the median. Okay, so the median is 2. All right, now remember, I told you there can be 2 modes, and this one does have 2. What are they?
0 and 2.
Yep, 0 and 2. Okay, so those occur the most often. Great. All right, so the next thing we're going to do is we're going to talk about something called the expected value. That is a weighted average. of possible outcomes. Okay, so the expected value is the weighted average, okay, of your possible outcomes. The weight for each outcome is the probability. So some of the stuff that we're doing in this section, and actually more heavily in the next section, is related to our probability work. So the weight for each outcome is its probability. Okay, and then for expected value, we're going to use that in example 2. You will often see a table, and the probability distribution of successful free throws is going to be given in this table. So this will be given to you. So the number of good free throws, n, the values for that are 0, 1, 2, and 3. So this information will be given to you in the table. Okay, and then the probability of those, this time the probability is given as a fraction. So sometimes it's a fraction, other times it's a decimal. Okay, but all this information is given to you. The key word is expected. So when it says find the expected number of successes, that means we're going to have to use this weighted average. Okay, so in a lot of your classes, you actually do have weighted values for different categories, right? Like your tests are weighted a certain percent, your homework's weighted a certain percent. That happen in some of your classes, right, automatically in the grade book. So do you guys know what happens with your average homework scores times the weight? Oh, I just told you. I said what happens to them, but I already said it's times. They get multiplied together. Okay, so that's what you're going to do, is multiply them by the weight. Okay, so to find the expected value, you're going to multiply each value times the probability. Okay, so the expected value times the probability. Okay, so 0 is weighted at the value of 3 over 20. And then we're going to add that to the weight of making one free throw, which is 3 over 20. Okay, notice how this is 1/5. So the denominator is not 20. Okay, and then this would be 3 times 1/2. Okay, and when you think about your expected value, think about the weights that these carry. Which one has the most weight? Which number has the most weight here? 3, because that's half of it, right? And all these are going to be less than half, okay? So our number should be closer to this side than this side here. All right, so we're going to calculate this without the calculator for the first part, just to help you prepare for that no calculator SAT, PSAT section. So when you're multiplying by fractions, 0 times anything is just what? 0. And then 1 times anything is itself. And then when you're multiplying whole numbers and fractions, what do you multiply? Yeah, numerator. So 2 times 1. So what would this fraction be? 2/5. What would the last fraction be? 3/2. Okay, and if you're doing this without a calculator, to add fractions, what do you want? Yeah, common denominator. So the common denominator of 25 and 2 is what? 20. Here's a hint. You can just always make it the biggest one if those two numbers go into it. So what would you multiply by 5 to get to 20? 4. So then you multiply the top by 4. 2 times 4 is 8. Okay, you know how we reduce fractions? When we're getting the common denominator, you're doing that in reverse. Okay, and then 2 times 10 is 20, so 3 times 10 is 30, and now we can add them all together. So when you're adding fractions, add the numerator. 3 and 8 is 11, 11 and 30 is 41, and then the denominator stays the same. Okay, now with your SAT, sometimes it's short answer, other times it's multiple choice. So let's go ahead and write this as a mixed number. So how many times does 20 go into 41? 2. How many left over? 1. Okay. Can we turn 2 and 1/20th? Can we turn 1 over 20 into a fraction? I'm sorry, into a decimal from a fraction? That it does, you're very close. So what I would do, if it's 1 over 20, I would try to make it to something out of 100. Because then I could write it in the hundreds place, right? So what would you multiply by 20 to get to 100? 5. So if you multiply this by 5, if 5 goes in the hundreds place, this would be 2 point. So if you put 5 in the hundreds place, what has to go here? 0. Okay, so the expected value is 2.05. This is the expected value of good free throws for this problem. Okay, which makes sense because we said 3 had the value of a half. 1/5 is 20%. Okay, which means that you have 70% on this side. Also, another thing with the tables, you'll notice if you add all these together, the probability should be equal to what number? What's the whole with probability?
1.
Yeah, 1. 100%, which is the 1. Yep. All right, great. The next thing we're going to talk about is box and whiskers plots. And actually, last hour a lot of people remembered the box and whiskers plots. How are you guys feeling about box and whiskers? Pretty good? All right. So with the box and whiskers, and sometimes these pop up on the SAT too. Sometimes there's the stem and leaf. Sometimes there's the box and whiskers. What a cute little name for this thing. Okay, so what is the box and whiskers? The reason why this is something we talk about in terms of statistics is it shows the spread of a data set with the 5 key points. So the 5 key points that we're looking at here are the minimum and maximum values. Min-max values. So let's look and see where those are on the box and whiskers. So the min and the max make up the whiskers part. Okay, so that's going to be your first and your last point. Then we have the median, which is right in the middle. Okay, notice if they use the median and not the mean. Tomorrow we're going to dive more into why the median is, well, can be more helpful than the mean. Okay, why the number in the middle can be more useful than the average. Okay, and then the first and the third quartiles. Do you guys remember these? The first and the third, you do? Okay, good. Don't worry if you don't. We are going to go over how to calculate those again. And then we do have something called the interquartile range. These are the data points that we are going to make sure we include on our box and whiskers plot. Okay? So with the quartiles, okay, the quartiles are just the medians of the lower and upper halves of the data set. Okay, so it's the medians of the lower and upper halves of your data set. If there are an odd number of data values, do not include the median in either half. So the median is either one number or it's an average of two numbers. If it's an average of two numbers, that means there's an even amount and you can split them up. But if there's not an even amount, you just don't include the median. Okay? And then the interquartile range is the difference between the first and the third quartiles. So difference means that you're doing what with those? Subtraction. So when you find the difference, all you have to do is Q3 minus Q1. Okay, and the reason why that's something that we indicate on our graph is that it represents the middle 50% of the data. Okay, so it represents the middle 50% of the data. Alright, so we are going to make a box and whisker plot of the data that's given below, and we are going to find the IQR. So, two things. We're going to make that plot. We're going to find the IQR. So the first thing we want to do is order the data from the least to the greatest. Okay, I also like to make sure I know how many values I have, like if it's odd or even. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to give you a minute to order the data from least to greatest. So remember what I told you before? I like to find the lowest number, and then I just mark it off so I know that I've already done it. Okay, so let's check to make sure we did the ordering right, and then we are going to find the min, the max, the median, the quartiles, and the IQR. So the minimum is what? 4. So it's always just the lowest number. The max is always the highest number. Okay, and now that we've labeled these, right, if there's 9 values, then there's an odd amount. That means 7's in the middle because I have 4 on the left side, I have 4 on the right side. Okay, so if there's an odd amount, there will be just 1 in the middle. Okay, so now we're going to find the quartiles. So the quartiles, the first quartile is the median of the first half of the data. So median of the first half. Because there's an odd number, I'm just not going to include the 7, so I'm just going to look at these values. So to find the median, I have to find the one that's in the middle. The problem is there's an odd number, so how many are in the middle? 2, the 5 and the 6, right? So how do I find the median if I have 2 in the middle? Yep, add them together, divide by 2, you find the average. So we're just going to do 5 plus 6 divided by 2. 5 plus 6 is 11. 11 divided by 2 is 5.5. So our Q1 is 5.5. Okay, and then in a very similar fashion, when we're finding the Q3, this is where you find the median of the upper half. I guess I should have said upper and lower. I said first half, it's the lower half. Okay, and this has a similar type of situation where you have 2 in the middle. Okay, so for Q3, I'm just going to add those together. 8 plus 9 divided by 2. So 17 cut in half. Okay, so really just cut 16 in half, which is 8, and then it'll be 8.5. And that's your Q3. Okay, and then the last thing we have to find after the quartiles is the IQR, and this is where you are just going to subtract. So the IQR is the third quartile minus the first quartile. Okay, which means this value should always be what? What type of number? Positive, yes, because the upper half should always be greater. Okay, so this is the interquartile range. Okay, so when we do the box and whisker plot, we're going to label our key values on the number line. So I'm going to help you with this. So if you look at your min is 4, your max is 10. I'm going to make my number line and then just start labeling. I made my number line a little long last time. You don't have to have a straight edge, I just like the way it looks. The main thing when you do your number line, you should try to just space them out the same. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so once you have your number line, when I say label the key values, that's going to be what we found in step 2. So I start by putting my points on there, so the minimum is 4, so make sure you label 4. Okay, that's your minimum value. Okay, your max is 10. Okay, and then your median is 7, so here's 5, 6, 7. Go there. Median. Okay, and then you have your Q1 and Q3. So if it's 5.5, just this is 5, so add your 5.5 in there. Okay, and then add your 8.5 in there. And really, I can space those out a little bit better now that I'm looking at that. Okay, and then, so after you have the 5 points, we're going to do the connecting. So you connect first dot to second dot, straight line. And then the last 2 dots, straight line. Those are your whiskers. And now we're going to make our box. And then we have a straight line through the median. My box could use some leveling, it looks like. And then the last thing is the IQR. That's the last thing we're going to put on there. So the interquartile range. So just like they show you up here, see how you have the interquartile range below? We're going to do the same thing. Okay, so the interquartile range goes from Q1 to Q3. So it's from 5.5 to 8.5, and you just have to label it IQR. Right, so when I say like label your key values on the number line, I just want to see like this is at the 4, this is at the 5.5, the 7, the 8.5, the 10. So those are the numbers I want to see. Okay, and then of course your IQR. Make sure that you label that as well. All right, what questions do you have for me on the box and whiskers? Is that coming back to you from your earlier days? Okay. All right, so the calculation of the variance and standard deviation, this should be new information. Like I said, if you do take some of the stats classes that we offer, this is something you'll be exploring a lot in there. So variance and standard deviation, these are 2 measures of variation, okay? So a measure of variation is just a value that describes the spread of data in a set. And there's many different measures of variation that we use. For instance, the range, the interquartile range that we found earlier, the variance, which we're going to go over now, and the standard deviation, which standard deviation is a big one. How many of you have heard of that term? Do you know what it means? It's hard to explain if you haven't studied it. Even if you have, if you haven't put it into words. So I'm going to give you some official definitions and then some plainer definitions. You can hopefully make some connections with. So there's going to be some special symbols. Okay, for variance, we have this little guy. Do any of you know? We see the 2. That's a squared. Do any of you guys know what symbol that is? It is Greek. So you know how in the English alphabet we have capital letters and we have lowercase letters? It is a lowercase letter. It's a sigma. Do you guys know what capital sigma looks like? It looks like an English letter. E. Did you? It was on the board when you guys came in. I don't know if you guys saw it. Yeah, but I didn't know if you guys noticed it. Yeah, it's it looks like this.
Oh, yeah.
Yep. Next year you'll actually do some things with this. Do you guys know what this means in math?
Even, odd.
No. It's like a, yes, it's the sequences, the sum. Oh, sorry. It is sigma. Yeah, so you'll do different sums with different sequences, and they use it in calc as well. So this is denoted by sigma squared. So if I say sigma squared, this is what I mean. It does kind of look like a fancy O, so we'll practice that. Now what that means is it is the average of the squared differences from the mean. So right now that might not make a lot of sense to you, but I'm going to walk you through this process, okay? So it's the average of the squared differences from the mean. You can see we have a table down below. We're going to find these together. And then the standard deviation is just the lowercase sigma. So if this is sigma squared and this is sigma, can you think about how we can go from this to this? Yes, great. It's just like x squared to x, right? You take the square root, that's what you get. So it is the square root of the variance, and then it's one of the most common and useful measures of variation. Okay, and again, remember that guy is sigma. Okay, so sigma squared and then just sigma. Okay, if there's a low standard deviation, that tells you that the data is close together. So the official definition is that it is clustered at the central tendency. Okay, so if there's a low standard deviation, we say that's clustered at the central tendency, while if it is a high standard deviation, then you just think of what would be the opposite of clustered together. Yeah, spread out, far apart, yes. Okay, so data that is spread out from the center. So if there's a low standard deviation, that means all the values are close together at the middle. Okay, so they're close together and they're also towards the middle of the data. Okay, so a lot of times when we think about, data sets, we think about scores, right? So when you find the middle of the data, okay, if there's a low standard deviation, that means all the scores were very close. Whereas if there was a high standard deviation, you probably heard me say before, oh, these tests were all over the place. Like, some people did really well, some people didn't do well, and then there are people spread out in the center. This would be a high standard deviation set. Okay, so values are spread out from center. Okay, and each other. And we'll talk more about values that can skew that data and how the standard deviation fits into it. Tomorrow is when we go over that. Okay, so for now, what we're going to do is we're going to use some tables to help us break down when we want to find the standard deviation. So if we look at example 4, it says find the mean and the standard deviation. Okay, and then the data set that's given is for the number of people getting on and off a bus for several stops. And we're going to be introduced to another new symbol. So this says find the mean, and the symbol for the mean is an X with a line above it. Okay, so this is the mean symbol, the average. Okay, so we've already practiced finding the average today, so we're going to do the same thing as before. And yes, we can use our calculator for that, but we guys just write the sum over the total. That's what we're going to do. Okay, so the mean equals, and I'll give you a minute to find the sum. We'll put that over the total. Okay, so we're going to add those together. Okay, what was the sum? 63. And then there were 9 total values. This one just happens to turn out nicely. So this one is exactly 7, so the mean is 7. Okay, so that's the first part. Now we have to find the standard deviation. So remember up above, we talked about the standard deviation, okay, is the square root of the variance. And so in order to do that, we're going to find the variance and take the square root. But the variance is the average of the squared differences from the mean. So what we're going to do is we're going to take our data values, we're going to find the differences from the mean, and then we're going to square them. So the data value, we call that the x value, and that is just going to be every data point that's given to you in the set. You don't have to put them in order. So the first one is 6, I'm going to put 6 here. Second one is 8, then I have 7, 5, what comes after the 5? 10, 6, 9, 8, 4. Okay, so that's your first step, is you're just laying that out. Now, this is the data value minus, this is the x with the line over it, which is the mean. So what we're going to do here is x minus the mean, which we just found. The mean is what? 7. So we're just going to do x minus 7. So if I plug in 6 for x, because that's what it is, 6 minus 7 is what? Negative 1. 8 minus 7 is 1. 7 minus 7 is 0. Okay, and you don't have to put that for all of them. I just want you to know how we're getting these numbers. Okay, so 5 minus 7 negative 2. 10 minus 7 is 3. 6 minus 7, negative 1. 9 minus 7, 2. 8 minus 7, 1. And 4 minus 7, negative 3. Okay, so again, the reason why we're doing this, the variance is the average of the squared differences from the mean. So this is the difference of the mean and the data value. So now the only thing that's left to do is square it. Okay, do this in your head because it'll be faster. Okay, so if you square negative 1, what do you get? 1. If you square 1, you get 1. 0 squared, 0. Negative 2 squared, 4. 3 squared, 9. Negative 1 squared, 1. 2 squared, 4. 1 squared, 1. And then negative 3 squared is 9. So this is when you square a number, the value will always be positive. Okay, so I do recommend squaring those in your head. Again, I think it's faster. And then remember that they're positive. Okay. And then step 3, we're going to find the variance, which is the average of the squared differences. This is the squared differences. So all we have to do now is find that average. Okay. Okay, so what we're going to do is the symbol for variance is that sigma squared. Okay, so what we're going to do is we're going to take these squared differences and find the average. So we're going to add 1 plus 1, which is 2, 0, plus 4, which is 6, plus 9, which is 15, plus 1, which is 16, plus 4, which is 20, and then 1 and 9 is 10, so altogether that makes 30, and then we still have the 9 values. Okay, and then 30 over 9. Okay, and you can use your calculator when you're doing this on your homework. I just want you to know that this, if you do 30 divided by 9, 9 goes into 30 how many times? 3, with how many left over? Yep, and 3 over 9 is 3 1/3, and we are going to write that as 3.3 repeating. Okay, like that. So, I do want you to use your symbol, okay? So that's the symbol for the variance. Okay, and this example did ask you to find the standard deviation, so we are going to do that. Sometimes they will ask you for the variance as well. Okay, so to find the standard deviation, we wrote down how we find that. To find the standard deviation, what do we do to the variance? Yeah, you just take the square root. Okay, now when you do this, do not round until the very end. And then when you do, we're going to round to the nearest hundredth. Okay, but when I say not to the very end, I mean don't take the square root of 3.3, okay? What we're going to do is, we know that the variance is 3.3 repeating. So when you take the square root, okay, we got that by doing 30 divided by 9. So when we take the square root, we're going to take the square root of that entire thing. So we're going to do the square root of that answer. Okay? So this is going to be 1.8, and then do I round up or keep it the same? No? Yep, we're going to round this one up. So 0.8, it'll be 0.83. Okay, and then this is your standard deviation. And you guys can abbreviate standard deviation like that. And then the solution for this one is the mean and the standard deviation. So the mean we found was 7. The reason why I write that as the solution is because those are the two things that they ask for in the directions, right? Is that find the mean and the standard deviation. Okay, so I'm going to give you some time to do the one on the back. And then I'm going to give you about a minute to do step 1. I want to make sure we have the right mean, because if you don't have the right mean, then the rest of the table is going to be off. Okay, so we're going to find the mean and the standard deviation of the data. So go ahead and find the mean, and then we'll check in a minute. Okay, so check your mean with mine and make sure that you did that correctly, you found the correct average. And then the data values are just what you're given in the set. Every value minus 21.9. Now we're going to square that. Okay, so I'm going to give you some time to do that. Notice that some values are the same, right? So 18 appears a few times, 19 appears a few times. So you don't have to do that all 3 times. Just go ahead and write it in there. All right, so once you find the difference for these, obviously calculator is fine because you have the decimals. And when you're using your calculator, I wouldn't even put in the negative, right? You know it's going to be positive as your final answer. So just do the 3.9 squared, 4.9 squared. Okay, and then again, some of them are the same. So if they are the same, then you can just use that for the same boxes. Okay, so anytime there's an 18, a 15.21. Alright, so then the variance is going to be the sum of row 3 divided by the total number of values, which there are 10. Okay, so you get 22.89, and that leads you to the standard deviation. So to find the standard deviation, you're always taking the square root of the variance. Okay? And then your solution is the mean and the standard deviation. That's what the problem asks you.
I think I just forgot to add that.
I'm going to put up the calendar. Okay, and then I did post for you the new chapter 8.